brain tired now. So let's go. 8:30, baby. 8:30. Compound AC3H. Feel like we don't wait for question on this. Draw a fully displayed structure of compound A and B. They are hydrocarbons. All right, so what's the name of compound A? C3H6. C3H6. Prop what?
Propene.
C3H8. What's the name of it?
Propane.
I don't know more. One of these compounds react with bromine dissolved in tetrachloroethane. So it's aqueous bromine. Which one of these react with bromine?
The propene.
All right, so compound A would react with it, right? And what would be the observation?
From purple to colorless.
No, bromine water.
Or red brown.
Or orange. The colorless. Write an equation for this reaction. So propene C3H6 reacts with bromine water. Listen to me. See, Ariel come and disturb my class right now. Gas C3H6Br2. Draw a fully displayed structure of the product in equation B. So why I'm drawing propene now is because your product is going to be depends on what you draw for propene. So here I'm putting in my double bond between carbon 1 and 2. So when I react it, my double bond is going to be converted to a single bond. And then to the carbons that were in the double bond, I'm going to be adding Br and Br. So the name of this would be propane. What's the substituents? Bromo. So how many bromo do I have?
2.
Dibromo. And where are the dibromos?
1, 2. 1, 2.
Draw fully displayed structure of compounds X, Y, and Z as shown below. The fully displayed structure X, Y, and Z are shown below. X is a alcohol because it have the hydroxy. So X is propanol, Y is a ester. This ester is methyl propanoate, and Z is an acid, which is butanoic acid. State the homologous series to which each of these three compounds belong. So we say this is alkanol or alcohol. This is ester. And then this is alkanoic acid or carboxylic acid. State the two types of compound which are soluble in water and give a reason for your answer. So which ones are soluble?
The acid and alcohol.
Ariel, learn. Let's go. Which two are soluble? X and which one?
You will never have to go.
Both are?
Polar.
Why we not do no more fermentation, Kristen? We can say that?
Yes.
Anaerobic fermentation is the process by which yeast without oxygen decompose sugars to glucose, and then glucose is broken down to ethanol and carbon dioxide. So you can watch the previous video if you never watch it. So go watch it back. We talked about fermentation several times. You one reason why high temperatures are not suitable for anaerobic fermentation. What's the reason again?
To denature the enzyme.
All right, so soaps are formed from alkaline hydrolysis or saponification of natural fats and oil, which are esters. Ethyl propanoate, an ester of relatively low molecular weight, is hydrolyzed by aqueous sodium hydroxide. Draw fully displayed structure of the hydrolyzed product A and B. So here the molecule will split. The part where the C double bond O is what we're going to add to that part.
OH.
No, alkaline hydrolysis with sodium hydroxide.
O negative and plus.
Yes, brother. She
Yeah.
wanna write. And she not read her writing yet. Not sure. So where the molecules split, we're going to add ONA to the C double bond O. I mean, wake her up. What may I do? You come and confuse me. O negative NA. And then to the O part, we're gonna add H. What's the name of the acid? What's the name of this compound? Sorry, what's the name of this salt? Sodium propanoate. State 1. Name one byproduct of saponification of fats and oil. What's the byproduct?
Glycerol.
And state 1 disadvantage of synthetic cleaning agents over soap, non-biodegradable. And it also contains sulfates and phosphates, which are potential pollutants. All right, the structure of propene and 2-aminopropanoic acid and amino acids are shown below. So it says, draw the structure of the polymer formed from propene using 3 units of the monomer. So here, the monomer is opening up, so the double bond is converted to a single bond. And then we just repeat this 2 more times. So be careful when you're adding the CH3. Make sure you add it. So that's the partial polymer. What type of polymerization would 3-aminopropanoic acid undergo? What type of polymerization? This amino acids undergo condensation polymerization. And the general name for it is polypeptide. And this polypeptide is protein. I'm writing it all the time. Outline 1 chemical test that can be used to distinguish between propene and the polymer. So we can use acidified potassium permanganate. So it would turn what? What's the observation? If we add propene, acidified potassium permanganate. It would do what?
Purple to colorless.
So it's gonna turn from purple to colorless. What about the polymer? Polymer KMNO4 KMNO4 remains purple. Full display structure of hydrocarbons A and B are shown below. Write the name of the homologous series to which compound A and B belong. A belongs to
Alkene.
I love them two compound here. Alkane. So this is alkane. Write the general formula for each homologous series named in I above. General formula for compound A, alkene.
CnH2.
Next one.
CnH2n plus 2.
A and B react with chlorine but under different condition. State one necessary condition for which B to react with chlorine. So B is the alkane. What's the condition?
UV light.
Let's make sure so this is E. And then the one here A. Draw a fully displayed structure of the organic product formed when compound A and B reacts with water. So with A, you have to be careful when the double bond breaks. So that means that the chlorine is going to be on carbon 2 and carbon 3. Or carbon 1 here and carbon 2 there. Clear?
Yes, miss.
So when you get a question like this, you have to be careful where you're putting your chlorine. For B, B was what? Butane. So only one of them is going to be replaced. So may I add the chlorine for any one of them? Only one chlorine we add in. The question below is based on the following reaction scheme. So we have compound D, which is an alcohol. It undergoes oxidation and it forms a acid, which is ethanoic acid. So the alcohol that we had must have been ethanol. Clear? Clear how we get ethanol?
Yes, miss.
Yes, miss.
So E is ethanoic acid. E is reacting with a compound known as G to form J, which is an ester. So let us name the ester in J. What's the name of the ester? How many carbons are in the alcohol? One.
This one now.
Methyl ethanoate. So G must have been what? G must have been methanol. Clear how I got that?
Right?
Yes, miss.
Why you
State the role of K2Cr2O7 in the conversion of D to E. So it's the oxidizing agent. It oxidized the alcohol. It's a balance equation for the reaction with E and solid metal magnesium oxide. So E is CH3COOH. Remember that this is the H that's going to be replaced with magnesium, but magnesium is 2 plus. So it means that the salt, we will need 2 ethanoate ions in the salt to cancel out the 2 plus from the magnesium. Mg. This is aqueous. And we form water. Because it's 2 ethanoate ion, we're going to put 2 in front of ethanoic acid. Clear? No answer. We're hearing.
Yes, miss.
Describe one chemical test that could be used to identify the gas given off from the reaction of compound E with solid calcium carbonate. So solid calcium carbonate is going to react with an acid. So when acid reacts with carbonate, which gas is produced?
You want people to clap for?
So when bubble, CO2 in calcium hydroxide or lime water, what would we observe? White would turn cloudy. So white precipitate would form. So if CO2 is present, a white precipitate would form or the solution would go cloudy. State the name of the homologous series to which J belongs. J is a ester. What's the functional group in ester? In case they had asked you, C double bond O or O, COO. That's the functional group. We do this already, right?
Yes, miss.
We do it already, right? Same question, different here. A is ethanol, B is butpentane, 3 is propanoic acid. Say the homologous series to which B belongs. B is alkane, C is alkanoic acid or carboxylic acid. Compound A burn, that's ethanol. With a clean flame in oxygen. C2H5OH. I'm gonna balance it, so I'm tell me what to do. Remember, water is a gas. Give me the balance equation. What we put in front of carbon dioxide. Like every time we do this. I'm gonna do it. How much in front of water?
3.
What's in front of oxygen?
2.
No. 4 oxygen layers though. And then over here, so we have 3. 1 is in this, so we have 6 left. So put 3 in front of oxygen to make it 6. Say which of the 2 compounds A or B is more soluble in water? Again, this is a repeat. Which one is more soluble? A or C? A or B, sorry. A or B, the alcohol or the alkene?
Alcohol.
A is polar. Which one reacts more vigorously?
Yeah, acid.
Aye. Remember, say something, say studying, you have to do the same material over and over again for it to cement in your brain. C loses H plus more readily than A. It's a balance equation for compound C with the metal. C is propanoic acid with the metal sodium. So H here is going to be replaced by sodium. So form C2H5 COONA plus H2. How do I balance this?
Put 2 in front of everything except for the H.
Good. Describe one test that could be used to identify the gas that is produced in the reaction when compound C reacts with sodium. I'll do it again. Come, let's go quick and fast. Hydrogen gas.
Please highlight explain over the gas.
And what will happen to it?
Observe and
Squeak
squeak
it
it
up.
up.
Squeak it up. Yes,
If H2 is present, let's explain the O to that cup. Compound A and C reacts to form an ester. So A is ethanol, C is propanoic acid. So it says state the name of the catalyst. So the catalyst is esterification, right? So concentrated H2SO4 and heat is the condition. Draw fully displayed structure of compound D. So we have propanoic acid. Nothing new, then I come with from the organic person. Although whatever they come with, you are prepared. All right, so this is called ethyl propanoate. Then I will change the structure then. 2 natural sources of hydrocarbon. Remember, we don't answer that. We don't write down that, but give me the answer quick and fast.
Crude oil.
Crude oil and what?
Coal.
You can skip this too, right? Cheer this 2015. Like, all of the generic question I come like them, I just straight repeat. We do this already, right?
Do you want that?
Yes, miss.
What is that your name?
Propyl ethanol.
Which homologous series does W belong to?
Esther.
Ester. Draw a fully displayed structure. Say splitting the molecule right here. So to the ethanoic acid, we're going to have ethanoic acid. Kind of hydrolysis acid. So put OH there and then H. All right, so the structure name is, so pick any structure. A is ethanoic acid. B is propanol. Glucose, a monosaccharide, can be represented by HOH circle, OH unit. State the name of the polymer of glucose. So what is the polymer name? So it's polysaccharide or?
Starch.
And then the linkage in the, what's the linkage in glucose? Then glucose we have an ethyl linkage. So me, now all me I gotta do, I know that each molecule is linked via O. So this is what one molecule of glucose looks like. So it's linked via O. This is another one, linked via O. This is the third one, linked via O. Clear? You know I link it, so I not have to draw the three of them and take out the water. Do I need to do that? Do you want me to do that?
Yes, miss.
Yes. So this is me, I take out water. So from the molecule here, I take H, from the one here, I take OH. So I'm going to take OH and H from this. So I'm going to take H from that, and I'm going to take OH from here. So the OH is going to go. So I'm left with this bond only, this, then O, then this, then O, then this, then O. Clear?
Yes, miss.
Once I know the linkage between them, and then if you don't put in the linkage, I'll link the two polymer. A student is asked to distinguish between a sample of glucose and its polymer. He adds water to separate portion of glucose and its polymer and stir. What happens to glucose in a water?
Dissolve.
I mean, it's me have sense.
And starch is
No.
going to remain insoluble. Yes, Michael, the absent. All right. The monomer shown undergoes condensation, polymerization. Name the type of polymer formed. So this is amino acid. What type of polymer is formed from? All right, so let us say I wanted, so give me the same question like this, right? We are going to draw the partial polymer. So this don't ask you to draw the partial polymer. I know the linkage. I know the linkage is, so I'm going to use the linkage part and then draw it over and show you. So I know the linkage is C double bond NH. So all I'm going to do, I put this as well. The N, one N I go, so I'm going to have one H left. Then I go have one next box here, so. Then we go have C double bond O here, so. Then we go have one next NH here, so. Because that's the linkage, so this, I link this. And then I put in one next box here, so. And then I put in C double bond O. So let me draw it now, show you. One come here, so. H, box, C, double bond, OH, N, OH. So this is how we are going to take out this OH and this H. So you see we have this here, so right? And then from this end, the H here will come out. Then over here, so we take out OH and H. So you see, so this represents this right here, right? This now at the middle, the linkage. Then this is what's left when we take out that. And then this now at the linkage, them two here are going to form the linkage here. When we take out the water. And then this, our have left. Let's see. So you see? It works better for your acid and your glucose. Yeah. Clear? Clear when we get that?
Yes, miss.
Let's take it out.
Yes, miss.
All right, so the type of polymer formed is what?
Polypeptide protein.
Okay. Yes, sir. There's the one for you. Make sure you're not study section. Anyway, I'm going to send a video of them tomorrow. I'm probably send them tonight because knowing me, I'm not going to remember nothing tomorrow. What's the use of this?
To make enzyme,
Enzyme in the body.
hormone,
Enzyme or hormone in the body. Growth and repairs of body cells. What is now? 1, 2, 3, 4, 5. So this is which one? So C5H3 and 2, 5 and 2, 7 and 2, 9, 9 and 3, 12. So which homologous series this compound belongs to?
Alkene.
General formula. CnH2n plus 2, 1 use. Like me over this. I'm done. Where answer? Pentane. A pentane make bubble, right? It make foaming agent. This already, yeah, it make foaming agent.
music can be with a solvent too.
Blowing agent. Yeah.
Component in gasoline.
I realize that then just a rinse and repeat the question because I want different years, you know. The 2017 and we never do 2017 earlier blowing agent or component in gasoline. Solvent. Define the term structural isomerism. Molecules with what? What they have?
Same molecular formula but different structural formulas.
So the goal I forget 25 out of 30 and the exam for 2 organic questioning, but different what? Structural formula. Draw fully display structural draw pentane to never draw 2-methyl. This is 2-methyl. Draw the methyl. So this is 2-methyl. 2-methyl. What is? Butane. Condense. Compound P as a condensed molecular formula. Same pentane. Oh, same question. Me repeat the page here. Q has a condensed molecular formula CH3, CH2, COOH. So Q is propanoic acid. This is new. Ish. Explain why Q is soluble in water.
Because it is polar, so
So,
it dissolves in polar water.
all right, you know the pre. In a solution of compound Q, acidic or basic. Is a solution of compound Q acidic or basic?
Acidic.
Things that are acidic does what? So it dissolve in water to produce H plus as the only positive ion. Compound R CH3, CH3, CH3. So this are 1, 2, 3, 4. So this is what? What the name of this?
But butene.
So the double bond is between the second and the third carbon. So butene reacts with bromine to form compound S. State the X, so it's bromine, so we're going to assume it's bromine liquid. Bromine liquid is red.
Brown colorless.
Draw a fully displayed structure compound S. So with so the double bond is going to be between the bromine is going to be added between which carbon? The double bond is between carbon 2 and 3. So which carbons would have the bromine? Bromine. Carbon 2 and carbon 3, because the double bond split. I'm going to add a bromine to each carbon that was in the double bond. Clear?
Yes, miss.
Yes, miss.
Yes.
All right. So compound P reacts with hydrogen gas in the presence of a catalyst to form compound Q. P again?
Pentane.
P? I can't have P here, because P I want alkane. P no want alkane. Yeah, one pentane. Reacts with hydrogen gas in the presence of a catalyst to form compound Q. I must see other Q. I want different set of compound them. Them I want different set of something. That's a different set of P and different set of Q. What's the catalyst? So the only thing that could react, P must have been an alkene, sorry, right? And if it reacts with hydrogen in the presence of a catalyst, the catalyst is nickel. The condition is 150 degrees Celsius and it is 5 atm. And this would have been an alkane. Clear?
Yes, miss.
Yes.
One physical property of Q depends on the number of carbon we have. So if it have 4 or less, we're gonna say it's a gas. If it have more than 4, we're gonna say it's a liquid. So on different P and Q is, so we'll skip that. The following diagram shows the structure of compound R. So this is R. R has 1 carbon here, so 2, 3, 4, 5. Right? 5. So it would be what?
Pentanol.
I don't know, just pentanol. There's the OH.
Or 2.
So the OH is on the second carbon, so it's penta-2-al. Clear?
Yes.
Condition required to dehydrate ethanol. Why condition for dehydration? Concentrated or
Phosphoric.
good, and temperature? 170 degrees Celsius. We now define structural isomer again. Oh, see P here. See the right P here. So P here, so 1, 2, 3, 4, 5. So this is a pent-1-ene, right? Clear? One physical property. Yo, this is a liquid. No. What else is it? State one chemical property. So you get one reaction. Addition. Reaction. With what? With halogen, you can say reacts with hydrogen to form alkene. You can say reacts with water to form alcohol, sorry. So them something their chemical property. Draw fully displayed structure of compound P and one of its isomers. So that's a pentene. So we could have draw pentene as another isomer. So the isomer would be pent-2-ene. We could draw 2-methyl bute. I'm not draw them, but you can draw them. So you can draw 2-methyl bute 1-ene, 2-methyl bute 2-ene. You can draw, yeah, I think that's it, based on the double bond. So you draw pent-1-ene here, so put on the H. Draw like a girl. As much as I'm tired. Pent-1-ene. Next time, remember to call the girl and cancel out tomorrow. Yeah, eat this. So here's so one fat and alcohol here. I could do this quick and fast. Soaps are prepared from the saponification of oils and fat. Using compounds to represent the structure of a fat, draw the structure of the products expected. So the molecule is going to split, right? So we're going to have RC double bond O, and in saponification we are using sodium hydroxide. So a 3 of them here are going to form. And then where the O's are, we're going to have H. So we're going to have one HO here, so one HO down here, so and down here, so we have one next HO. So we're going to just put in back the rest of the molecule. What is this called? What's this part of the molecule? So this here is the soap. And what's up here called? A number of vegetable oils are unsaturated and are liquid at room temperature. They can be solidified by the process of hydrogenation, for example, in margarine production. Write an equation to illustrate the process of hydrogenation of an oil represented by compound D. So in hydrogenation, it is this double bond here that is going to be converted to a single bond. So each carbon that was in the double bond is going to get what? Each carbon, the double bond is going to break, and what we're going to add to the carbons that were in the double bond?
H.
So each of them going to get a H. I draw it out. I add one H to one here, so single bond, one H here, so one H here, so. And then I draw back all of them something I don't know what them be. I don't care what they are either, because all they want me to know is that it's the double bond I react. So then could I draw the whole world, I draw it back and just write the parts that are reacting. Clear? I'm gonna do one question and I will cheer that. The question was a circle the functional groups representing a molecule. I'm gonna look for it. All right, the first stage in the process of refining crude oil to produce more value-added products is fractional distillation. Name the property upon which fractional distillation is based. Difference in boiling point. Name the lightest and heaviest fraction. The lightest fraction is refinery gas.
Refinery gas.
Heaviest section is butane. One use of the lightest fraction. Cooking gas in homes. What we use butane for?
Make roads and roof.
Roofing. Road surface. Consider the structure of compound A below and answer the question which follows. So compound A, again, we don't know we don't care what the molecule is. All you have to do is to look on what they say is reacting and find the functional group that will react. So this compound have two functional groups. It have the hydroxy and it has the carbon-carbon double bond. So it has two. So it says draw the product formed when compound A reacts with each of the following. So if it reacts with bromine, which functional group is reacting with bromine?
The alkene.
The alkene. So I'd put back everything else. What did they? Me not care about them. So I'd put them back. And then where the alkene is, I break the double bond to a single bond. And each carbon in the double bond, what am I adding?
Br.
So I'm not care. Which one of these are going to react with sodium? Which one of functional group are going to react with sodium? The hydroxy. So the hydroxy, the H from the hydroxy is going to come off. And what's going to be bonded with the oxygen? Na. And then we just write back this. I'm in a business about that. Clear? So now care how big the molecule is, just look for the different functional groups and make sure that you can find them. Draw the partial structure of the polymer formed when compound A undergoes additional polymerization with other molecules of A. Use 3 molecules of A. So again, we don't know what it is. We don't care what it is. We draw back what we have. So the polymer would look like this. This up here, so with the OH. And then down here, so we have CH. The double bond are going to open up, right? Right? So this is one of it. Clear? So me just repeat this again. I'm going to repeat it again. Clear?
Yes, miss.
I'm going to catch this up here, so. B represents the partial structure of a polyamide. So let's look at where the molecule is. The linkage is here, right? So if they had asked us for the monomer unit, we'd break the molecule here. So the monomer would have been an acid and an amine, so it would be amino acid. Clear?
Yes.
Name the type of polymerization process involved in the formation of B. So we already know so this our condensation. polyamide B. Polyamides of type B can undergo both acid hydrolysis in the lab as well as enzyme hydrolysis in the body. Draw the monomer B. So again, now you ask to draw the monomer. So when you split the molecule here to the C double bond O, what we're going to have? We add back the OH. To the amide part, what we're going to add? The H. Clear?
Yes,
Yes.
miss.
State one difference between the reaction conditions required for acid hydrolysis compared to the hydrolysis compared to enzyme hydrolysis of polypeptide. So in any hydrolysis, we have to boil the ester. So we have to boil the substance that we are doing. And so acid hydrolysis requires boiling, right? Whereas enzyme hydrolysis requires body temperature. Structural isomerism again, draw but1 in, but2 in, draw another isomer of C4H8. So other than but1 in or but2 in, what are the two other isomers that we could have drawn?
Two methylpropene.
Now which other one? Cyclobutane. One physical property of C4H8. I'm going to say a guess. Ethanol reacts with different reagents to form products with the functional group shown in table 3. What is meant by functional group? What is a functional group? Last question. Functional group is the atom or group of atoms that is responsible for the chemical property of an organic compound. The atom or group of atoms responsible for the chemical property of an organic compound. Here we have ethanol. Complete table 3. Identifying the reagents or condition or reaction condition. Draw the fully displayed structure of the product. So some of us have done this question already. So alkene has carbon-carbon double bond. So the name of reaction we remove from alcohol to alkene is called what? Why name my reaction we move from ethanol or alcohol to
Dehydration.
dehydration? What's the condition?
Uric acid.
Sulfuric acid, 170 degrees Celsius. So we're gonna form ethene. It's not come a long time. Here we're moving from ethanol to an acid. The ethanoic acid, what's the name of the reaction? So the reaction is called oxidation. What's the reagent that we use for oxidation? That's why I can't find a pen. Okay. Oxidation, why oxidizing agent we use glass? We just talk about them all the time.
Potassium permanganate.
Okay, we use potassium permanganate. What's the observation that we would see? Purple to colorless. So here we're forming an ester, right? So here you would have to put any because they want the product of the ester. So we have ethanol, we need an acid, so let us use ethanoic acid. What's the condition for esterification? Concentrated sulfuric acid and heat. So the ester would look like this. The acid part have 2 carbon. And then we say we use ethanol. Mhm. So we stand next to one another. But that's it for tonight. We're all tired. So let me save this. Upload this to the drive. Somebody please text me and tell me to send the answers. So let me go on my phone. I just send it over quick and fast. Yes, so Ancha, my time we do not done. This is it. This was our last class together.